creating the level. So this will be the YouTube video for creating the level and getting that stuff in there. So as a quick reminder, those of you who are obviously just live here with me, you just saw this. I want to start putting in the level stuff into the grid here. Now we have in our game data, we have our level, which is a vector of these types. And we looped through and created them. So we actually have them in here. And we have our types, which is all of these. Now, where do I want to put our so we're gonna need our meshes in order to sort of go with these types. I can store the meshes in here, but that feels like then types is maybe a little bit too overloaded. I'm thinking we probably just want to have meshes. Let's create a meshes.rs. We'll go into library and we'll mod this. So what I'm thinking of is we can actually use this as a struct or as an enum. I'm thinking this should be a struct. Okay, so our struct meshes, and then we're going to have basically what are the meshes that we're going to care about here. So if we look at our types, the first thing we're going to care about is the floor. So maybe let's just start with that. We're going to get the floors out in the level. So you use GGEZ, graphics, mesh. All right, so and our mesh here. If that's the only thing we care about, they're going to want to create a new and then actually create all these meshes for us. So impl meshes, hub function new. We know that when we create meshes, we're going to need to return that game result. So let's go ahead and also get that in here too. So we're going to need graphics, game result. We know we're going to need context. In mesh, we also know we're going to need the mesh builder, the game params, draw, the draw mode, not the draw params because that's when we actually draw. What else do we need? Probably a point too. And that should be it for there. All right, so in meshes here, what are we going to take in new? I don't know if we need to take anything in besides the context. Right, that's what we need also. Oh no, we brought that in. And we're going to return a game result that holds all the meshes. All right, so then we're going to return, okay, meshes. And obviously in here, we need the floor. So I'm thinking, let's create a bunch of private functions in here, static methods that are going to create these for us. So we want you to be graphics. Let's do create floor mesh. Mr. Halsey, rating with a party of 28. Welcome, welcome, welcome. Mr. Halsey, thank you so much for that raid. How was your stream? I saw a notification earlier that you were working on, which, was it the space? Is it your space? It's like a space station game, I think. Or am I thinking about the wrong streams? I haven't been able to see it recently, but that's awesome. Thank you for coming. How was your stream? How was everything? Everybody who's here, I need to comment this entire thing out if I want to show you what I've got. Oh no, we still got errors. Oh, comment you out too. Okay, that's no errors. What we have right now, we're at the early stages of building a running game, and we also have a game data that's allowing us to define what this runner game is going to look like inside of a vector or an array, essentially. We're using this as a way to like learn Rust, show off Rust, and that our level is going to be coming in right around here. Let's see. It was good finishing up stream and multiplexer again. Ooh, that's cool. That's pretty awesome. Is your game in a playable state yet? Also, Evil Halsey and Mr. Halsey, is that actually your name is different than your stream name? That's cool. You don't see that very often these days. Okay, so what we were about to do is create the meshes, sort of like starting to begin with, which is we want the floor. I'm not doing I don't have any sprites, I don't have anything else. So just like we did this entire same game in P5.js, which is based on processing. Now we're doing it in Rust and GGEZ. So if I want our meshes, we want to create our floor mesh. Create floor mesh is not going to take in self because we're not going to have that yet. And so I'm going to take in a context. So immutable reference to the context. We're going to return a game result, and it's going to be a mesh inside of here. And so what is this floor going to look like? Well, what do we need in order to create our floor? We're going to need to know what the what sort of our standard size is, like a standard unit, a world size. If we come and take a look at our game object, let's actually go to the game data. We don't define what the floor width or height is. What we're thinking of is a floor takes up an entire cell. So we're going to want the cell size. So we're going to want a standard, a world unit almost. So in here, let's take in a width, which should be an F32, and a height, which should be an F32. And then we also probably want a color, although this floor mesh, we probably can just create the color right here. I don't know if we need anything else for this. And our location is actually going to be defined somewhere else. With this, all we're really going to care about is just pretty much this. All right, let's go with it. Let's do it. We're going to do our mesh builder. Mesh builder new. We're going to make these this is going to be a rectangle. So we do need rect to come in here too. We have our draw mode. This is going to be a fill. Our bounds of a rect. Okay, so we're going to have a rect new. And then what is this going to be? So 0.0, 0.0, and then our width and our height. And remember, we're making everything start from 0, 0, and then go out from that, including the grid. So everything is sort of based upon that. Our width is going to be our width, and our height is going to be our height. Okay, and then we're going to have our color. Well, we need color too. Okay, so color new, and then this is going to be based upon 0 and 1. Let's actually do from RGB again, and then we'll just sort of be able to create whatever the color of the ground that we want to be. So let's go find a good. Do any of you have a good idea for a color? Otherwise, I will find one in here. We have a dark blue background, maybe something like this. It's like a very dark red. How about this? 102.51.0. Okay, so that gives us the color. Out of this, let's see, this is Mesh Builder new. You're off of you. We need to build you. What are you? Oh, this is off of just the rectangle. I think I'm... Okay, so rectangle. Oh, mode bounds color. And then in here, we're going to .build, pass it into context, and question mark this. And actually, I don't even need to semicolon that. I don't even need to question mark it. We're returning the game result of this mesh. And so here we are. We have our mesh here. This is going to be our floor, and that is a self with the capital L, and then create floor mesh, pass it into context, and then we need a width and a height. So let's actually turn this into a, we don't really care about a cell, like a cell width. Let's just call this like a world width. And a world height, and take these in here. And so then when we call this mesh, we're gonna have to pass those in. So then, oh, we need to question mark u here. So that way it returns the game result if it fails, otherwise we get this new mesh. And this is just yelling at us because, well, even though we're calling create floor mesh here, we're not calling new. So therefore that's why it's yelling at us. Let's go ahead and change that. I guess we don't need a point now. We're gonna need a point later when we add new ones, but I guess we can ignore this right now. And we don't really need graphics. So that should be good here. And it's just telling us that we're not using it. Let's change that. Back to library. And then we're gonna store the meshes in here. So exactly the same thing. We need to create the meshes before we store it into the game state. So meshes, new, pass it in that context, the world width and the world height. So this is actually going to be based on the game data. Game data dot cell size. And we want to question mark this, and that gives us our meshes here, and we can store them in. All right, now remember we created a cell mesh, and that's actually being created and stored inside of the grid. Let's actually change that. Let's make this here. So we'll do like a cell. You're a mesh. We know we're going to want a width and a height. We want to turn a game result with this mesh. And then we've already done this over in the grid. Let's go grab this out of here. We'll just, I'll just cut this out so we know to come back. Paste this in here, and so we're going to return Now what do we need? So we need the width instead of cell width. And you're going to be height, like that. You need to be a capital C context. And it's looking for white here. So let's bring that in. All right, so you're happy now. So let's also store, we have our cell, it's a mesh. Create cell mesh, pass it in the context, and then the world height. Question mark U, and we're all good for this. We'll come back to the main library. So you're happy, we're now getting our meshes. We now have the 2 meshes in there. We want to change the grid, so we're not going to store the cell mesh anymore here. Which means when we create the new one, we're not going to create you, and we're not going to store you. We're just going to actually create the cells. That's all it really cares about. And that means we don't need the context here anymore either. And we don't need the world height, do we? It doesn't really care about the size of this. It just cares about... Actually, no, wait. I was wrong. We do need that. We need the cell width and cell height so we can store those away. All right, so we're good there. In here and draw, hey, don't do that. We want to now take in a reference to the mesh. So the cell mesh is going to be a reference to a cell, a mesh, which we have that right here. And then when we draw this, drawable, so here, this is really just going to be this cell mesh. And it's already a reference, so I don't need to like tell it to be a double reference. That's actually a thing that you can do, and it can cause a little bit of problems. So this should still work for us. Now we have some errors. Function takes 3 arguments, so we don't take in, let's see, we don't take into context anymore. So we're happy there. Expected 2 arguments, so when we draw, we also need to pass in a reference to self.meshes.cell. However, if I do that, I need this to be public. No more errors, so let's go ahead and run this. Nothing should change. Like the cells should still be here and everything is good. So what's next? We want to draw those. We want to draw the actual floor in because we have the floor that's part of the mesh here. We have the grid, which in order to draw the floor, we need to create these game objects that are the floor and put them in. So what is that going to look like? So we need to go into their game objects and actually like have something in here to draw. So I'm not going to have it store the mesh. It's just going to store like what that specific mesh is. And it's maybe like, we'll like pass the mesh in when we get to the draw part of it. But for right now, when we put our struct in, we need it to have a height, it to have a width, it need to have a location. So let's do that. So we have a width, a height. We need to have a location. And this is going to be, we can either do this as a point to and then do our vector math separately, or we can do this as a actual vectors. I'm thinking we can probably just do vectors here. So use GGEZ and algebra, and we want a vector 2. So this is going to be a vector2 that stores F32s. And I think, well, we're going to want to store the type. And the type, I'm going to bring that in. So go one level up, and then the types. So it's going to be some type that's stored in here. You're upset because we shouldn't be using like the type with this. So let's actually change this to like my type or something like that. Then let's go ahead and import game object. Okay, so when we create a new one, we're going to want to take in what its width is, what its height is, what its location is. Let's actually do like a location X and a location Y. And it's obviously, it's my type. And we're going to return a new game object. All right, so width, height, location. All right, so location is actually not quite as easy. It's going to be location. That's going to be a vector2 new with the location X and location Y. And then my type. Okay, so that gives us the game object. So we can now start inserting these in. Oh, we're going to need an ID. We need an ID, which we happen to know we're going to be making them U64s. So let's also take in an ID and storing that in here too. All right. So what are you upset about? Missing fields ID. Let's see, ID is new coming in here. ID and ID. That's fine, right? Oh, comma. Missed a comma. All right, so now we want to create our game object for every floor. So let's just create like one manually and like place it into the grid and like see where it comes in. So in our main library, we already are using our game object. So pubmod game object, let's use it now too. Our game object is going to be added into the grid. So let's just create one randomly here. We can create like a piece of floor. So we can just actually just floor equals game object new. All right, so what do we need? ID, so let's just give it 0 as the ID. We're definitely going to want to, like create these objects and have like something like figure out what those IDs should be. So either we're gonna have to store the IDs here and like figure out what the next ID is and auto increment, or we're gonna want like the grid to insert new things and we hand that in. And like the grid could be in charge of like adding a new floor piece, adding a new something else piece. That's something that we might want to like consider. Okay, so perhaps let's do that here. Let's track in our game state. We'll go next object ID, and you're going to be a U64. That means we have to set this up here. So set you to 0. We're going to use you as the next object ID. Remember, there's no plus plus, so I'm going to have to then increment that myself. Plus equals to 1. We made it mutable, so we can do that, and we're going to store that here. So we can actually use that elsewhere in our game if we need to, like when we need to create new objects. Who knows, maybe we won't ever need to actually create new ones. Maybe I don't actually need to store it in here. All right, what's next? We need our width. So our floor width we happen to know is going to be our game data cell size. So I'll actually do these on new lines. So then our height. Our location. So where are we going to put it, like location X? We don't have to actually care too much right now. Let's put it just like 200 right and maybe like 200 down. And then our types. So we'll make you a floor. And there we go, we have a floor. Now if I want to insert this into the grid, we're gonna have to come back into the grid and add in another function for this. So let's add into the grid. Mutable self, because we're gonna be mutating ourself, and we're gonna have the object to add. So the game object, which is a type game object, we're gonna be taking ownership of this. And I don't think we need to return anything at all. If we do run into errors, then we can return that error at that time. All right, so for our game object, how do we know where to add it in? So we need to do a little bit of math to figure out like the cell-wise where this is. So if we take our location and we divide it by like the width, then we're gonna get the x index. So let's figure this out. So x index is going to be the game object dot location dot x divided by, and it's going to be the size. So we have cell width and cell height. It's not super, excuse me, not super helpful here. We want the number of cells. So we can get that with self.cells of like the first one, and that gives us a row dot length. Now we have some problems here. First of all, location is private, so we need to go into game object and make you public. Next, you're saying, hey, look, you're trying to divide an F32 by a usize. Well, that's not helpful. Let's convert this to a usize. And there we go. So we now have an X index, which is this usize. We're going to do the exact same thing for the Y index. We could just do the first one here because we just want the down. Okay, so now we know the X index and the Y index. We want to now check to see, are we attempting to add them into like inside of the grid? Because if we go outside of the grid, we're gonna have like an out of bounds error. And maybe we can just like let ourselves crash. That's probably not the best of ideas. But like if we just try to throw this in there, let's see what happens. We're going to do self.cells of position Y index first, X index. That gives us the cell, and the cell is a hash map. So we're going to now insert. The key is going to be the game object .id, and then the value is going to be the game object itself. And that's it. Now you are a U64. Field ID is private, so let's go ahead and fix that. Make you public. All right. Now we have this add in here. So it's going to add in. Let's go ahead and use that. Our grid is now going to have to be mutable. And we're going to immediately just say grid.add the floor. Great, we've added this floor in. It's not super helpful at this moment in time. We can't actually see it in there. We might be able to debug mode the grid and see that printed out. And if we do that, let's see what happens. Let's debug a reference to the grid. Now, what are you yelling at me about? Grid doesn't implement standard debug. So let's go change that. So in here, derive debug. All right, what's next? Game object doesn't implement debug. Okay, let's fix that. Types doesn't implement that. Okay, let's fix that. No errors anymore. Okay, let's try it out. Thread main panicked at index out of bounds. The length is 10, but the index is 20. Ooh, okay, so we've got a problem there. My math wasn't correct. So, right. I did the math incorrect. What is a panic? So a panic is basically a crash to the desktop. We crashed out of here because it's like, hey, you attempted to insert this into the grid and our vector length is 10, but you try to go into length of 20. So the problem here is when I do this add in, I need to know what the cell size is in order, because I need to be not dividing this by the cells like the number of cells, but by this, like this only works if the cell size is 1 pixel. I need to do this by the number, like the cell size. So we actually do need to store this away. So let's do that. So cell, actually we have this, cell width and height. Let's just use that. So for the x and x, this is gonna be self.cell width and self.cell height. There you go, that should be a little bit happier. Now this is gonna be usized by F32. I converted, let's go ahead and remove u. Now these indexes are F32s. So we need to take all of these and convert them to as basically just a usize. I think I can do like a u like anything else, but I think a usize is what it wants to be as an index. And that allows me to get, insert in, and it should be much happier. Here's our entire grid. This is a fun sort of depiction of it. And we should be able to find in one of these, here's our game object that we put in. We could probably like figure out, did it go into the correct spot? We know that the width is 50, and we put it at location 200, 200. 50 divided by 200 is 4. So I think 4 over and 4 down. So let's look in here. So this is 0, 1, 2, 3, 4, and then 0, 1, 2, 3, 4. Okay, so it put it into the correct grid location. So it's in here. Excellent. The next thing is that we want to draw it to the screen. So drawing is going to be a little bit interesting. We're going to want, so in a game object, we want to now have a draw. Okay, so we're going to take self. We're going to have to take a reference to all the meshes. Which means that we need to know what they are. And we're going to return a, let's see, use GGEZ. Okay, so we're going to want to do a graphics. We need a game result and a context. We're also going to want to use GGEZ, graphics. What are we going to want in here? We're going to want the, let's see, draw params. I don't know if there's anything else. Okay, so you're going to be a game results. And so we're going to draw, like we have the location where we're going to go. So what is this going to look like? We're going to do graphics, draw. Oh, we need a context. Okay, so bring in our context. Bring in the drawable. Okay, so what is our drawable going to be? That's kind of going to be based upon what which mesh, like out of here, we're going to use. So let's see. Let our mesh equals. This is going to be like just a reference to the mesh. So it's going to be equals to. We're going to match off of our my type. So it's going to be self.myType. All right, so what are the types that can be in here? We already have types. So types, if we're a floor, then we want to reach into meshes. So meshes dot the floor mesh. And that's pretty much it. Now, if it's anything else, we don't care about it right now. And we're just going to do nothing. So this is going to be interesting. We need to match off of this mesh, but I don't want to like repeat this drawable over and over and over again. So I probably want to just, if it's not one of these, let's go ahead and just like straight up return an error. And let's go into our, let's see, game result is it wants to do a game error. So we probably want to do a game, go into our custom errors. Not that. I want our custom errors. Oh, errors, that's what I called it. And we couldn't, so this error is going to be, we couldn't find the, could not find the game type. So could not find type. We're also going to have to now handle this like the game error, because we can't return two things. So we're going to call this like a game and a game error. We can even call this like a GG. Game error. And then we're going to hold the, what is it? I think it's GGEZ game error. Game error like that. So, okay, in our game, we're now going to return super custom error. We're going to return a result. which has, I mean, it's going to be basically just a game result or a game error. And actually, we just don't really care about this. It's going to return nothing or a custom error. That's it. So in here, we have our mesh. We're going to return an error with a custom error unsupported. Where is it? Could not find type. It's like that. Semicolon U. So we're going to get the mesh out of here. Guaranteed. If the mesh isn't there, we're returning with our error. Then we're going to be able to draw and pass it in. So we have our context. We're going to pass it in this, this mesh. Now this floor is private, so let's go fix that. Now notice it's actually saying that we're taking ownership of this here. I don't want to do that. I want to get a reference for you. So now you're a reference to an error, so I can just pass in the mesh and then the params here. Drop param, let's create a new one. That's basically the default drop params, and then I can move it to the appropriate spot of where it really is, because those meshes don't really know where they are. So .dest, and then this is going to be a brand new point. Remember these we have vector 2s, so we need to convert the vector 2 into a point, and I think I can do that with an into or a from. So we can do here is a point to from self dot location, like that. Now we can question mark this. No, we can't. We can't question mark this, unfortunately, because it's saying, hey, you can't convert this into our custom error. It's just, it isn't going to allow us to do that. So we do have to match on this. If it's okay, we don't really care about that. We want to then just return a okay, like that. And that returns our result. Also for you, we don't really care about you. Then we're going to have our error. So if there's an error, we're going to get an error, which is that game error. And we want to return a error. No, it's going to be a custom error. GGEZ game error, and then pass in the error. Like that. That's good for you. And then we're returning this. So save, and we're all good there. What are you upset about? Okay, types floor. Meshes floor, so could not move out of here. So I actually want to return a reference here. So I only want a single reference. I don't know if you noticed there was a double reference for a second. That is kind of causes some problems. Okay, so this will now draw out with the correct location our mesh. Let's see if we loop through in our draw. So if we tell the grid to draw, we're looping through. Now this is just creating, like drawing the mesh itself. Let's go ahead and for each of these, we have the y-index, so we have the cell. We're gonna want this now. And we're gonna now loop through the cell. So for game object in cell, it actually wants me to make this a tuple. We're going to take in the ID and the game object. And then we can say, okay, game object dot draw. Now we have to pass it a reference to the meshes. So a reference, which means, well, we have the cell mesh here. Let's actually just make this all the meshes. So a reference to all the meshes. So we don't need a reference there. We just do meshes. And then the context goes into. And I think we need to question mark this and semicolon. Now, problem. This is a custom error and not a game error. So now we're going to need to return a custom error and handle this ourselves. So you're happy, but this draw is not going to be happy anymore. So first of all, drawable cell mesh. So we happen to know that you are meshes dot cell mesh dot cell. So we're happy there. Reference to meshes. So use super game object. Hold on for this. Let's do use super, want the game object, and we also want the meshes. All right, so meshes.cell, mismatch types, found struct, we want a reference to it. Okay, so reference to you. What is left? All right, so custom error. You are not a custom error. We want you to be a game result. So a result that has nothing or a custom error in here. That's going to make you incompatible here. Can I find custom error in his scope? So let's bring that in too. And now we're going to do error-driven developments to figure that out. So couldn't convert this error to custom error. So let's do this. We're gonna have to match on you. Now, do we really need to do a match for this? There's another pattern that I haven't shown you yet with Rust, and that allows me to like not do the match where I do like the OK and return. Although in this case, like it probably works out nicely for us. So it might work out here. I'll probably find a better way to do the if-let for you later. But we're gonna have the OK. We don't really care about what's coming back in it. And we're going to just continue on. We don't really care. So in that case, you know what? This is a perfect time for if-let. We only care about this if it errors. If there's an OK, we don't want to return or do anything at all. So let's not do the match. Let's undo this for a second. Instead of a match, we're going to do if let if it's an error. So if it's an error type from this result, and I want to get the actual error in here, equals the result of calling graphics.draw, and then it's now the normal if statement, except I have access to error. So I want to, at this point in time, return. And this is going to be an error, a custom error, a GGEZ game error, and pass in the error, like that. And there we go. So this allows me to avoid that match when I don't care about one of the arms. If I only like care, you know, I don't care about one of the two arms. So this allows me, this cleans it up just a little bit. If-let like is the only time I've ever really seen this is in Rust. It's a really nice pattern. I like it a lot. Okay. We have 4 errors. Let's take a look. Mismatch types, expected struct meshes meshes, found GGEZ, graphics mesh mesh. So what is this? Self grid draw. So this is the event handler for the game state. Right, we want to pass in the actual meshes. So like that. What's next? Couldn't convert the error to GGEZ error game error. So this is like pretty often when you start doing your own custom errors, you have to go through and like convert these all. So we're going to do the exact same thing. We're going to do an if let and convert this to our custom error. So this is going to become a result. We don't really care about the good, the good times, and a custom error in the bad times. So if let we want to return error, custom error, GZ game error, pass it in the error. You're happy there, and then with you, I actually want to, again, the same thing here. You can actually error out. So let's go ahead and do this too. And if we reach the end here, we can return OK. Now with you, let's see, you're a custom error. So actually, I can just return error and this straight up error and pass it straight through. In fact, because you're a custom error, I don't need to do this if let, do I? I can just do this self grid draw, and I can question mark you because you are a custom error. All right, so, method draw has an incompatible type. So I can't actually return this. I have to return game result from here. So this is the end of our bubbling up. Okay, I got it now. I got it. In this case, we do want to just come back to here, question mark. Just do this, graphics present. We want to, so I got it backwards. We need to return a game result because the trait event handler tells game state, look, it has to be a game result. You're not changing that. So when I do this draw, I don't want to just unwrap it and crash. I want to handle the error right here. Now, if it's an OK, I don't really care. So we're going to do our if let. If we get an error, we want this custom error equals to this. But now we're going to match on this and take a look at what this is. Now, custom errors, like we can get a couple of these. Like we can get a bunch of like what this could potentially be. I think it could only be a GGEZ error, couldn't it? Like that's all we care about. Let's do that as a match then. We're gonna match off of the self.grid, and in here, so custom error, if it's a GGEZ game error, this gives us this error, but it's this game error we can return, error and the error. And that will be happy because it matches with this result, I believe. Now it's saying a mismatch types, expected standard result, found custom error. Oh, match with this. Right, you need to be an error. Oh, you're an error, the error. That's fun. So like, if I do this, so we get the error that's a custom error out of here. I probably want to do like a combination of the if-let and the match. So hold on. If I do like a double match here, match the error, then in here, here's our custom error, GGEZ game error. We get the error, which is the game error, and we return the error. And so that's happy with that. Now, if this isn't okay, we don't really care about this, do we? We just want to like ignore and not do anything. Oh, I think I can just do like that. It's a no operation. So because of that, I probably want to do, so I've gone back and forth in this a couple times. I'm going to settle on if-let. So if-let error equals this, but inside of here, that just allows me to get rid of you and you. We're not going to match. So that's the self-grid draw like this. Okay. So starting out. Then we want to match on this error. And then throw you in here. So if you're a custom error, then return this error. So if you're a GGEZ game error. Now, if you're something else, do we know what like the other things this could be? Like this is off of grid draw. So if in grid draw, looks like it can only be a custom GGEZ error for right now. So I'm gonna handle this with like everything else. We don't know what it's gonna bring in. So I want to just return. We probably want to panic and like just quit the game. So let's panic unknown error, and we'll just do that. So if we get the unknown error, we can do like unknown draw error. We can add in more errors in here if we like feel that we need to. Or if we get the unknown draw error, we can start like delving in and trying to like actually get what's happening. But we have no errors here now. Let's see if we can actually run this. There's our land. So here we have a floor. It's sitting right here, which is 200 over. So that was what? 4? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So it's in the correct position down. So perfect. So we can now create a whole bunch of these lands and put them in. So let's do that next. Also, I still have my debug statement in there. That seems like we don't really need that. In grid, actually that's in the library, isn't it? Here's our debug. Let's take that away. All right. So if I want to create the floor, I want to create all the floors. What I really want to do is loop through the level, and then for every single thing, we're going to create the game object and insert it in. So this sounds to me like we should probably have another function for it and call it from in here. So it's a function that's like populate level. We're not going to take in self because we're running this right here in new, but we are going to take in the grid, which is going to be a mutable reference to the grid. And that's pretty much going to be it. We're not going to return anything. We're just going to mutate the grid. Is that true? We're going to need the level. So we're going to need the level, which is a... We should probably just take in the entire world data. So the game data, which is a reference to game data. There we go. So then in here, populate level, we're going to take in the grid. So what do we need to do? We need to loop through the level, which is in game data. So let's do for, this is essentially going to be our type. So like, for individual like level cell, like I don't know what to call this, like level level piece. In game data dot level. This should yell at me because this is not private. Cannot move out of. Okay, so I don't really want to own you. I want to reference you. We're going to have our level piece, so we want to match on this. So match on the level piece, which means that it's going to be the type, the types. And we can see that right here. So it's going to be types. If this is a floor, what are we going to do? We're going to create the floor object. So let's take that out of here, put that in here. So we're going to create a floor. Then we need to put it in the appropriate spot. So, next object ID. We need to know like what our next object ID is going to be, and like continuously update this. So let's also take in next object ID. Which this is gonna be interesting. I'm gonna make this a mutable reference to a U64, which I don't know if this is a good idea or not. Sounds like a terrible idea, but we're gonna see if it works. So I'm gonna keep on be able to increment this, and then use this. So like we're gonna take our next object ID. We know that it's going to be a 0 to begin with. Add this in here. At the end of it, we're going to increment that next object ID. So let's take a look here. So match on the level piece. Types. Okay, so it's machine match arm. Let's go ahead and not do any of the other ones yet. So we're just going to ignore you for right now. What are you upset about? Expected U64 but found a reference to U64. Let's dereference this and get the actual value out of it. Okay, so the game data, that cell size, so it's a width and a height. So we know the floor is that width and height. The location, so where are we going to put this floor? So we're going to start with basically, well, we need to know where is it in here. So we're going to probably want to turn this into an iter and then enumerate. And that's going to give us, let's see. I don't think I need there. Yeah, we're going to get the reference to the types anyways. We're not, the iterator doesn't take ownership of it. So we're going to get the index. And then the actual level piece, like the level type. So let's do level type. Level type there. Okay, so that makes a lot more sense. Now for our location, we want to do a little bit of math. We want to take the size of the piece. So we know that the floor is like the entire game cell size. So this is going to be game data dot cell size times the index. and that's going to be the location X. And the location.y, I believe that in our game object, we have where it is. Not game object. Game data. Floor Y. That's where we care about it. Floor Y. Oh, nope. Go back to here. So this is going to be game data dot floor game data dot floor Y. We need to convert this. Do we need to? No, we just need to multiply this by the index. No, it's just going to be this. This is what it is. And then we set the type to that. And once we have our floor, we created the floor. We're going to insert this into the grid. So grid.add, and then our game object, which is the floor. You're complaining because we have cannot multiply usize to F32. Cell size is an F32, so let's go ahead and as usize. Or is it the other way around? Oh, right. I want to do the other way around. As F32. There you go. That will set the location X for it, and the floor is already in F32. So we have some errors, but we're not even calling populate level yet. So let's go ahead and do this. It should only do the floors to begin with. So we don't want to call grid add anymore. We created the meshes. We now want to call self populate level, hand it a mutable reference to the grid, hand it a reference to the game data, and hand it a mutable reference to next object ID. And then, because I don't want to forget this, otherwise everything will get the same object ID, at the end of each one of these, we want to increment the next object ID. All right. Binary subject, right, I need to dereference like that in order to increment it. All right. No errors. Let's see if this gives us a level. Look at that. So we have a level sitting in here, and this is based upon what we have in this game data.json. So if I change this, so we have floor space, floor, oh, we have start here, and then floor space. So floor start, floor space. If I change this to another floor, and I restart the game, I didn't want to create a new shell. Now is like all together. So we can now create the level through that array, which is really nice. We don't have to like worry about, you know, having code in there. So the next thing I'm going to do is start like adding in the rest of these. Like what does the rest of this really look like here? So what are we missing? We have floors. We need start next. We can actually look at our types. To sort of see what we're missing here. We're obviously missing a player. The player needs to go on a type floor. Sorry, on a type start. So we can add the player in next. The player is going to go in type start. All right, so if we have a start here, we're going to do, I want to create a floor first. It's a little bit unfortunate to copy this. Let's copy it for right now, and maybe we can like create another function to sort of help out with inserting these in. But we're gonna have the start come in at the floor level, and then I want some kind of like start flag up on top. So if I just do this to begin with, we should now have no gap in this third one. Perfect. Which means I want now like a flag, something, a mesh for our start. All right, so we're gonna want a width. Like how wide is this? I don't even know if I'm tracking like how wide the start or end is. No, we're just sort of controlling that inside of here. Let's actually, we don't really need that. So game results, a mesh. Builder. We'll do a fill. Okay, so our rect, we're gonna start you 0.0, 0.0. For our width, I guess we do want the width in here. But our meshes for like the start mesh, and we really don't care about the width and height of like the entire start thing. If I just have the flag of it, and like this is just like 5. And the height is, we do want that. So that creates our bounds. We're gonna have a color. Let's just make this green. And we're going to return, so we need to build it. Like that. Okay, so that makes you happy. Let's go ahead and pull this in. Okay, so that creates our start mesh. We do have one magic number in here, which is the width of the mesh for that. And so we probably want to like store this in here. We'll see about like how this ends up looking for it. All right, so let's go ahead and in our main library, we're populating the world. We have our start. We also want to create our start. All right, so the next object ID, which means when we create this new floor, we want to object increment here and down here. our width. Our width for this, I guess, like in this case for start, we can here, let's bring this in and do this the same way that everything else is doing. Width F32 will make you a width. That way we'll have the magic number only in one spot, which is right here. Our width, we're gonna say like here 5.0. And our height is gonna be cell size. Our location, so this is gonna be data size times index 2. Our location y, so we want to bring you to the floor y minus like a standard cell size. And then the type. And then we're going to add in, so we add in the floor, and let's go also ahead and add in start. Okay, so that adds in those two. Let's see if start is showing up, except we have some errors. Function takes 3 arguments. Right, so for self, we also need to take in, it's not gonna be the world width, is it? When we create in, we don't know that it's the world width. We just know that when we're creating our meshes, what the width of the mesh is gonna be. So let's do that. Is that true? No, that's not true. Because for the meshes, we really care about. So we probably want to bring in game data here. Just had an idea. Add fishes that jump out of the water in the drop game. Ooh, I like that a lot. I'll add that in to the idea list. Especially if I get some sprites. That'll make it look nice. Okay, so I probably want to refactor this to take in the game data. And if I take in the game data, then we can like grab the cell height and the cell width and like figure that out. We don't have game data in here, so we're gonna have to use it. Okay, so a reference to our game data. And then in here, so our floors and our cells are all gonna be the same thing. It's gonna be the game data dot cell size. Same thing for the height here. But as we're realizing is the flag, the start width should really, we should really have that. So let's come in here and add this in. So we're gonna have the start width. Let's make this like 5.0. But if we do this, we now have to come into the game data. And so in our raw, we have to take this in. So and F32. This will then collect that in, and so we're going to now, let's see, this is the raw game data. Oh, this, let's see, where is this? So here's the raw game data. We're going to get the start with load from file is going to grab that in there and put that in. So then when we load the game data, we want to now do start with is actually going to be self.start with. Like that. But that means we need to come down here to game data and load this in as well. Just like that. Okay, so that should make you less unhappy, which means that in meshes, we take in this game data, and you're going to be the start with. We're going to grab you out. So then you'll be the width and height, then you'll figure that out. Okay, so perfect. Now a lot of these are very similar because they're like rectangles. But this gives me the option to completely change these out, turn them into sprites without affecting each other. So I'm going to resist refactoring it in to combine them into one, because that can actually cause problems later. Let's go and fix our other errors. So in meshes new, we don't want to pass in the game data cell size. We want to pass in a reference to game data. And no errors anymore. Did I properly create the start? I did not. Okay, so what happened here? We got an unknown draw error. Okay, so we got that unknown draw error. So library line 106. Here we got this. Unfortunately, we don't know what that error is, which kind of sucks. So we're gonna need to figure out, it wasn't a GGEZ game error. What other errors can we get out of this? We know it's off of the draw, so grid. We're returning this custom error. Where are we returning a custom error? So we have the GGEZ error. But we have some question marks in here too. Is this the only area we have a question mark? It is. So it's in gameObject.draw. So let's go to gameObject and draw. Could not find type is one of them. Oh, look at that. Floor. Let's, we need to add in start. Okay, so if it's type start, we want to get the meshes.start out of it. And then everything else should be drawing the same. Let's see if that fixes the error. It does. Here's our start. At the left, we can actually like make a decision. Do we want this to be on the right-hand side? If so, when we create the mesh, we could translate that over. Let's go ahead and do that. So when we create the meshes, create the start mesh, we actually want this to be the width and a height for the start mesh. Come on. We want the cell width and then to subtract from that. So that's going to be a essentially a world width, F32. For our bounds, we're actually going to create a world width minus width is what we're going for here. Meaning up here, we're going to pass in now game data.cell size. If we do this, now our flag should be on the right-hand side of that cell. And we're gonna move, like we could run past that. Okay, that's perfect. So the location of this, of like the start, is actually in the top left right here. So that's a little bit interesting. But like let's not worry about that too much. All right. Let's go on to like what the next things are. The player. We need to put the player onto the game. So again, it's just going to be a game object, but with its own meshes. So what is our player? Our player is beautiful. It's the best player ever. We don't have a sprite for this, so our player is going to be a rectangle with a circle on top. We're gonna have the player, so we need the width of the player. We're gonna have the height of the player. I don't care about the world width, but we do need the head width, the head radius. And we're gonna return a game result with a mesh in it. Okay, mesh builder. All right, so new. Let's do, we're gonna base the player on like the body. And so like the head can be above the, like, so we're gonna have, well, how big is the body here? Let's go and take a look at this first. Body width is actually 25. Okay, so they're actually like half the size. So it's going to be fully encapsulated inside of one of the cells. So we're going to have the head up top and then the body down below. So we can do the head to begin with. So we're going to do a circle, draw mode fill, our location. So point. New, do we have a point? I don't think we do. All right, so where is this head going? We're going to go make it into the middle of the cell. So we want to take in whatever the width that we have divided by 2. So that's actually going to be our width divided by 2.0. But then the height, I want to take in the top, like, so essentially it's going to be the 0 plus half of the head radius. Our head radius is obviously going to be head radius. Our tolerance, we want ourselves to be an actual circle, so we'll do 0.1. And then color, we'll just make ourselves white. Or we can change our color to be like whatever color we want. Okay, so that's our circle. Let's then make our rectangle body off of that. And so circle returns, it returns a self. So I'm good to continue building off of here. So dot, now a rectangle, draw mode, fill, our rect, new. Okay, so where is our rectangle going? We also want to put this not into the center. We want to move it over into the center a little bit, or do we? Like I'm starting to think like double think this a little bit. I think I want my rectangle to be on the left-hand side, so the body moves into the middle of the body. Okay, so rectangle, we're gonna have 0.0, 0.0. Our width is gonna be our width, our height. Wait, how did I go into the color? Our width and our height. And then we're going to have our color, which we can also make this white. Then we're going to build this, pass in the context. And there you go. Here's our player mesh. We do remember that we have to go into the game object and handle this. Okay, so we'll get the player mesh and we'll just draw the player mesh at the appropriate spots. And then in the library, we now need to create this. So this is gonna be type. Okay, so for our player, there's already ground in the spot where we want to go, so we just need to create our player. Equals game object, new. All right, so the next object ID. Our width. So we actually have that in the game data dot player dot width, body width. Our height, game data dot player dot body height. Our location, and actually, you know, our entire width and height. Yeah, we're gonna just make it like the body width and a body height for us. So we're gonna be able to like, it's actually gonna look like what we had. We're gonna ignore the head for our size. What was next? After our height is our location. So our game data, I think we actually have to create, oh, just our location X and Y. If we take a look at this, we have the start X and the start Y. And then the types. So it's gonna be types player. All right, so we're gonna create the new player. Now these are all private, so we need to make body width, body height, start X, start Y. That is in the game data. In the player data. These probably all need to be pub. And then back to our main library. So we're happy here. Let's go ahead and add the player to the grid. And not forget to increment plus equals to 1. Okay, so that should add the player into the same cell that the start is. Let's see if that works. Oh, I got 3 errors. I didn't even notice that. Let's take a look at what we got here. Missing field player and initializer of meshes. Did I forget to actually put it in here? I did. See here, start, player, self, create player mesh, context. So the width of the player, so that's going to be the game data. Dot player dot body width. Game data dot player dot height, and then the head radius. Game data player dot head size. And let's not forget to question mark u. No errors. Let's see if that works. Oh, it didn't. Okay, so where is our player? I assume the player is in here somewhere. We need to. I believe that we're handling the player coming in. We are displaying them out. Oh, you know what? We're checking here for types like start. We actually don't even need this type in here. What we need to do is move you in to start like this. And we don't even need a handle types player. We're just going to put you in the same position where we're starting. And there's our, oh, that's a terrible looking player. So we are going to want to update this, make this look just a little bit better than what we have right now. And that's probably just going to be like sort of playing around with the sizes. But we can do this, and this is the best part about this. We can do this all inside of this JSON file. We can just say, you know what, your head size, you're not 25. We want you to be like, I don't know, 7. And our body height, we want you to be like 50. JSON for the win, exactly. So if I do that, how does this look? Well, now our body is like huge and our head is tiny. So let's try body width. You need to be like, I don't know, 10, just like slightly wider than the head size. And then probably like a little bit bigger head. We can make you like 15. And so like there's a lot of tweaking we can do about this. We can make the height bigger. We can decrease the size of the head. Probably just like make you 12 or something like that. And there we go. That player is not terrible now. And if I stop drawing the grid, if we come in here and we don't do this draw of the grid, then it's going to look like a lot better here because we're not going to see the grid lines and it's going to actually look like we have our platform and it's going to be all good. So it is after 12. So I've been streaming since 7 a.m. this morning. I did take a few breaks, but look how far we got. We have a level. I can't move the camera yet. We haven't implemented that. The level does go off to the side, so it's going much further off to the right here. We have a player, we have a start. These are actual gaps, so we'll be able to fall through them. Our grid is actually created, and yeah, everything's drawing to the screen. So we still have a few more things to draw. So we'd like a spike, for example. I think that might be it for the drawing out. So I'm going to go ahead and save all of this up to GitHub. Everything is saved up there. So it's going to be a work in progress drawing. So like drawing the level, like maybe like setting up the level. I'm going to push that up. If you missed before, you can go take a look at this code with Bang Repo. There's a link to the GitHub. So this is all open source. You can take a look through it. If you have suggestions to make, I would be happy to sort of like look through any pull requests or issues that you submit. I am doing this as sort of like a tutorial / for myself, learning game design patterns that I just went through a book for. So with all of that, I think I've got all of you set up. Let's go ahead and end the, put in a